So now we come to a few more properties of vectors, and it's quite instructive to learn about what is a negative vector. So I have a vector A going, let's say, due east, then its equal and opposite vector going in the opposite direction, so due west of the same length, would become the negative vector. So when you add these two vectors, you're going to get a 0 in magnitude. Okay? They cancel out in their magnitudes, and they can because of their directions being opposite. This helps us to do vector subtraction. We already saw vector addition, and we're going to do vector subtraction as the addition of a negative vector. So say we had to do vector A minus vector B. We're going to take vector A. If it was an addition and this was our vector B here, then this would be our resultant. It would be A plus B. But we want to do A minus B, so we need to take the vector B and flip its direction 180 degrees. So this is the negative of B, okay, negative vector. So we're going to now add A and negative B, and that's going to give us the resultant R, which is effectively vector A minus vector B. So that's how you do vector subtraction, okay, as an addition of a negative vector. Multiplication and dividing a vector by a scalar, these are important to know. Essentially, the scalar will just change the magnitude by that factor. So say you're multiplying by 3, then your vector magnitude is going to become 3 times as large. If you're dividing by 3, it's going to become 1/3 in magnitude. It will have no effect on the direction, so the vector will keep its original direction. So the resultant of multiplying or dividing by a scalar, which is just a number, is another vector whose magnitude changes, direction does not change, unless the scalar happens to be a negative. So if the scalar is a negative value, then the direction can change by 180 degrees, okay? So a vector A multiplied by -1 is going to be the negative vector A. Okay. Now we're next going to look at adding vectors algebraically. For this, we need to do components of a vector, okay? So we're going to first choose a coordinate system so that we have our x and y axes well defined, and let the vector of interest be some resultant vector R, okay? So the x components of the vector R are written like this, are represented by vector R with a subscript x. This means the x component of the vector R, okay? And that's the sum of all the vectors in the x direction. Similarly, the y component of the resultant vector is going to be the sum of the y components of all the vectors v. Okay? And to get the magnitude, we have to just take the square root of rx squared plus ry squared. And to get the angle theta, we're going to do tan inverse of the resultant y, which is the sum of all the y components divided by sum of all the x components. We'll look at an example of this, and that'll make it more clear.